Hi there, my name is Ian and I'm back with the third and final part of my sealed lead acid battery monitoring project. This is an Arduino code update where I have added a watchdog timer and a CRC data check on the data transmitted to the serial console. Since this code is probably going to be running for extended periods of time, I thought it was a good idea to put in some more robustness to the code. So a watchdog for the hardware and some checks on the data being sent to the console. So let's have a look at some code. So we have version 3 of the code here. We have only added a checksum and we have only added a watchdog timer. Both these pieces of code have been seen before in some of my other videos. If you want to go and check them out in more detail, have a look at some of my Paul McWhorter videos. Anyway, the watchdog's the simplest bit. You include the library, you initialize the watchdog, you turn it on, and then you periodically reset it. Now, what this does is, in this particular case, it's resetting the watchdog every 500 milliseconds. The timeout on the default watchdog is 1000 milliseconds. Now, what happens after 1000 milliseconds? Well, basically the watchdog kicks the Arduino, resets it. That's what happens. Clearly, that would mean that something's gone badly wrong in the code, so a reset of the hardware is probably the only thing you can do. That's why we do it. So, one thing to note about this though, is if you're running this code on a Nano, do make sure you have the new bootloader installed on your Nano, otherwise the watchdog just does not work. The new bootloader fixes some bugs, and without those fixes, the watchdog timer actually just hangs the whole Nano, requiring a power cycle of the Nano to recover it. Even this reset button on the Nano doesn't recover it. If you want to know how to update the bootloader in your Nano, go and check out another video on my channel. I've got all the instructions of how to do that, and I've done it myself several times, so I know it works. Now, let's look at the CRC checksum. This basically requires a few tweaks to the code. The first thing we have to have is a variable where we basically store the stuff we're going to send out the console. So instead of transmitting it when we have it and when we want to send it, we actually print it into a variable. I shall show you that in a moment. So where does this happen? Well, it happens down here in the console update bit. So we're wanting to share the results as job 2. We're sending data to the console. The data we're sending to the console is these voltages. So let's go and have a look at this send console data function. So that's down here. A few parts to it. The first part is all these voltages are floats. The first thing we do is convert those floats to strings. I'll explain why we do that in a minute. The next thing we do with these strings is print them into that variable that I showed you up top, this buffer. So we print those strings into the buffer. We then put the buffer through the CRC function to get the CRC. And then we print the buffer, put a comma, and send the CRC along after that. Okay, now let's back to these string float things. What are we doing that for? Well, sprintf on the Arduino has a limitation. That limitation is that the %f doesn't work. It's not supported. It's just an Arduino limitation. So in order to print the voltages, these floats, we have to convert them into strings first. That's the workaround. Now, let's have a look at the CRC check. That is an algorithm that has been known and around for a long time, and I have cribbed it. Details are in the in the header at the top, but ultimately what you do is you take the data byte by byte, run it through an algorithm, and this is the key part of the algorithm, this number here. That's what distinguishes one CRC algorithm from another. And at the end of running through that algorithm, you get a number out. The idea being that if the string, the thing you've just put through the algorithm, changes, the checksum will change. Now, we're only sending small strings, we're only working on an Arduino, so I'm only using an 8-bit CRC. Anyway, that is the limit and the extent of the changes in this code, and this code is now done. But let's have a look at some of the data that I captured from this code when I had it running for, I think it was about a week. So if I show you that, there we go. So if I look at that myself and we scroll around this, you see I've got, in this particular case, I've got thousands of lines captured. These are 5-minute readings, well, a reading every 5 minutes. So we have a header there, and at the end you can see the CRC has been added on. When you look at the numbers, these are the voltage that have been sent, and then there's the CRC at the end. Bang, 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 thousands and thousands of them. If I scoot down to the end, you see I've got 2040 of these readings. As I say, they had this running for about a week, I think. Anyway, that's absolutely fantastic, and I hear you saying, I understand what all the voltages are for, they're very helpful, tells me how my batteries are going, but this number at the end, what can I do with it? Well, what you can do with it is you can check that it's actually valid for that data, so that none of this data has been corrupted. So that's where I've got another bit of code to show you, which I have written, and let me show you this. Now I jump so that I can see it as well. What we have here is, what is it, 50 odd lines of Python, right? We've got a bit of Python code, which is the same CRC algorithm that you've seen in the Arduino code. It's just been converted to Python from C++. I just went through it one day, line by line, converted it. Thank you very much. Now, what do we do with this? Well, we're reading in that capture file, so those 2040 readings, we read them in, line at a time, in here. This is where we're reading it, and we extract out those voltages and the commas between them as it happens. So we're looking for the delimiter at the end, the last line, and we basically then take that piece of the line, put it through the CRC check, and if the CRC check fails, we will know that the line was corrupted or not. So if we quickly run this code, you shall see it. There we go. It doesn't take long at all. So what do we have here? If I make this a bit bigger, it will help you to see. So we run through the code. It's got a nice little banner. Tells you what it's reading in, tells you the headers it found, and then it starts reading in and checking all those CRCs. Now in this case, it didn't find any problems, because if there were, it would have told me there was a problem with a particular line. And it's told me at the end a summary. I read in 2040 lines and I found no CRC fields, so that gives me good confidence the data's fine. Anyway, this code for the Python code and the Arduino code and this results file, and I think even an updated fritzing diagram for the battery monitor hardware itself, all that will be on my GitHub site. The links down below. One last thing that I also did, which I thought you might find interesting, and if I jump to this screen and show it to you, and then I look at it myself so it's easier to talk about it, I've put together a page of the calculations I've used and how I derived them. So these are the calculations for working out the voltage reference stuff, where I'm working out the actual reference voltage that's been the nominal 5 volts on the USB line, and I found was never 5 volts. This is me working out what the real voltage being used for the ADC is, using the onboard 3.3 reference voltage that the Arduino has. This is the equations, how I'm using that. I've also included the voltage divider calculations, which is basically how we're working out the voltage being read through this divider. I'm reading what's over R2, but actually the battery is over R1 and R2, and this is me dividing down the voltage so that the 12 volt battery does not fry my Arduino. These are the calculations of how you work that out and scale it back up, so you can take what the Arduino reads and turn it back into something that is actually what was coming from the battery. As I say, this will all be on my GitHub site, links down below. Down below you'll also find comment pages and bits and bobs. If you have any questions, please ping me a line and I will do my best to help you. Anyway, as I say, this is the final bit of this project. I have a different mind worm in my head now, and that will be coming next. I've been playing with some 6502 processors, and I've got a software emulator for a 6502 on an Arduino. As it happens, it's not a Nano. I've put it into a Mega because it gives me a bit of extra RAM to play with. But that's what's coming next. Anyway, until the next time, have a great day. Bye bye.